Okay, here we have the tripod. It is composed of a top plate, a junction, an elbow hinge, a wooden core on each leg, a brass leg, and some bolts. This is actually created as a single part with many bodies. Here we have the top plate. It really just serves as a mounting between the actual Gatling cannon and the tripod. It's a simple padded plate, nothing really special. Here is the junction. This was actually made as a single body, then rotated to create 3 instances. This requires some specially defined planes. But apart from that, it's a simple part. This is what allows the legs to hinge properly. This is the elbow hinge. This interfaces with the junction and allows the tripod to hinge out. A fastener connects the two. Here we have the wooden core. It is a combination of decorative and structural piece which goes in the legs. It's of course made of wood. And here we have the brass leg. This one was likewise made as a set using the same rotated body method. It's still an assembly of padded features, nothing particularly special. And this is the bolt which holds it together. Simple padded feature, but without any special finishing.
Right, so right here we have a quick animation of the gears meshing. Again, we have 2 bevel gears that transfer power from the crank to the carry block. Alright, so what we have here is an animation of the action in action, I suppose. So highlighted blue, we have the carrier block, which is being driven by the yellow, that's our main shaft and other half of our bevel gear assembly. And then in green, that's our carrier, sorry, not our carrier, our breech bolt assembly. And then in red is the striker. So again, as we could see when I was kind of talking about the cam ramp, the whole thing moves forward up to a point, which is about mid-screen. And then once its motion forward and back is stopped, the striker, the bolt continues to move forward, which would compress a spring in between the red and the green parts. And then as you see, once it drops off the ramp, it flies forward, and then if there was a bullet in the chamber, it would strike the primer. Alright, and so this is what it looks like when everything comes together. You can see the crank turning on the right side of the screen and our barrels turning. So another interesting feature to kind of look at while we're in this view is we have that magazine fed into the side of the gun. This is kind of cool. For this we used generative sheet metal design. So this entire thing theoretically could be stamped out of a sheet of metal, and it has tolerances and relief cuts and proper flanges and everything it needs to hold the bullets and feed into the gun. There's holes for indexing and retention and all that. It was all done with GSD, so that was another important workbench that we used for this project.
Speaking as the last member that joined the team, I can firmly say we had a lot of issues with communication early on, me being in a different section and just getting together for the first time. We also had some architecture problems with file loss. That generative sheet metal magazine went through several iterations, some of which don't exist anymore. But overall, the team managed to come together for the final project.
As for just general team dynamics, we improved over the last, at least Daniel and I improved over the last project, the midterm project.
Definitely.
We scheduled more meetings properly. We allocated tasks a little bit more efficiently. Obviously not perfectly, but it was certainly an improvement. In general, this project has been a great learning experience for the part design, kinematics, and generative sheet design workbenches. We learned a lot, and we're really proud of how it turned out, so we hope it fits the bill.